All right, another factoring problem here for number 3 under your TrigProofs section. So here, this one looks really nasty. It looks much nastier than it is. There are a couple of tactics you can take. You can absolutely use U substitution like we did on number 2. So you can use U's, or you could even, U's and V's if you want to keep that cosine to the 4th in there as well. Just like we did with to the 4th, we can go ahead and say, all right, I'm going to let U equal sine squared and let V equal cosine squared. And that'll take those degrees down a little bit for you. You could also let U equal sine to the just sine and V equal just cosine if you would like. I think I'm going to go ahead and work it like this with just the U is sine squared and the V is cosine squared, just to knock down the degrees for me. So the really easy substitution here then is that this middle term becomes 5uv. And then cosine to the 4th is going to become v squared. And sine to the 4th is going to become u squared. I almost just wrote sine to the 4th, of course. And now that looks like a little bit of a nasty problem, but it's not so bad. Remember, we can split the middle is perfect for this situation, because with split the middle, we're going to keep our first two terms the same, 3u squared, and our back term here is negative 2v squared. And we turn it into a grouping problem, and grouping problems are awfully nice when you're working with kind of this multiple variable situation. So let's just work our numbers here. Our A coefficient is 3 and our C coefficient is negative 2. So 3 times negative 2 is negative 6. I need two numbers that multiply to negative 6 and add to 5. So those two numbers are going to be positive 6 and negative 1. So two problems with kind of tricky 6's back to back. On the last problem, we were adding to negative 5, and we needed the combination of negative 3 and negative 2. Here, we're adding to positive 5, multiplying to a negative, so we have to have one negative and one positive. So just be honest with yourself about what combination really works, because it can be really tricky. When you're putting your numbers into your split the middle, it doesn't matter which order you use. I think I'm going to go ahead and do minus 1 and plus 6. And then I need to, since my 5 had uv with it, these need uv's as well. Remember, the reason that split the middle is so nice is that, 1, it's a process, and 2, each step is equivalent to the step above. 5uv is the same as negative 1uv plus 6uv. Those are equivalent, so we haven't changed our problem. Okay, next up, split it in half and GCF. My first two terms have just a u in common. And my second two terms, 6uv and negative 2v squared, have 2v in common. So when I divide out the 2v, and remember, factoring is just division, if it helps you to write divide by 2v there, you absolutely can. I think that visual is helpful. The v's cancel. 6 divided by 2 is 3, and I have the u left. And that's matching what I have over here for my first term as well. And then when I divide negative 2v squared by 2v, I'm going to have negative, and then my 2's are going to cancel, and I'm going to be left with 1v. Nice. So my factored form with my u's and v's, and we need to put our sines and cosines back in. So u was sine squared and v was cosine squared. So u was sine squared, v was cosine squared. U was sine squared, and v was cosine squared. You always want to look for any more factoring that you can do. I don't see a difference of squares anymore, and I definitely don't have any other GCFs that I can take out. So that's our final answer. There is, you always want to look for those things. At the beginning of your problem, you want to look for that GCF, and at the end as well. You always want to look for difference of squares.